Hello, and welcome to section 3 of Unit 10. All right, so these notes are going to be a little bit shorter than the last ones. And this is my favorite form in this unit, descriptive form, which is another way to say vertex form. So whenever you hear descriptive form and vertex form, they mean the same thing. So when a parabola is written in descriptive form or vertex form, it's really easy to find the vertex. So I kind of talked about this a couple lessons ago, but now is when we're really going to use this. So descriptive form or vertex form is this. The generic form looks like this. So you've seen this before where we have x and y, and then sometimes we have a number here, or sometimes it's just 1, and then we usually have some numbers where h and k are. So whatever h is, that's our x value of the vertex, and whatever k is, that's our y value. Our line of symmetry is always x equals h, whatever the x value of the vertex is. So in example 1, if I want to graph y equals the quantity of x plus 4 squared minus 2, first thing I'm going to do is find the vertex. Whenever we graph quadratic equations, we want to find the vertex first and start our graph there. So whatever this number is, I have to change the sign. So it'll be -4, that's my x value. And then whatever this number is on the outside, that's the y value. Keeps the same sign. So -4, -2 is our vertex. So I go left 4, 1, 2, 3, 4, down 2. So our a value, when it's in vertex form or descriptive form, is always on the outside, the left side of the parentheses. If you do not see a number there, that means a is 1. I know a is 1. So whenever we're graphing quadratic equations, you can make a table if you want, find the y-intercept and all that stuff to graph these. But what I like to do is I like to use the pattern. So 1, 3, 5, 7, 9, ... It's just all odd numbers. And then we have to multiply it by whatever a is. But if a is 1, which it is in this case, then all these numbers are going to stay the same. So these are the average rates of change that I'm going to use to graph. So the first rate of change I'm going to use is 1. So that means I go up 1, right 1. So it's like a slope. I do the same thing to the left because it has to be symmetrical. Our next slope, or our next average rate of change would be 3. So I go up 3, 1, 2, 3, right 1. Do the same to the left because it's symmetrical. Then 5 would be our next average rate of change. So I go up 5, 1, 2, 3, 4, 5, and right 1. Up 5, left 1. So once you can't really go up anymore or down, if you're going down, that's when you stop with the pattern, but really you only need a couple of these. So there's our graph. So again, this is, the reason I like this pattern thing is because it's much easier to graph these equations using the pattern than making a table and doing all that work. So if the vertex has an x value of -4, that means the line of symmetry has to be x equals -4. Does this graph have a minimum or a maximum? Does it have a bottom or does it have a top? Well, it goes up forever, so it can't have a top, so it has a bottom or a minimum. And then what's the y-intercept? Well, we can't really see it on the graph, so that means I'm going to have to plug in 0 into x. So if x is 0, 0 plus 4 squared minus 2. So I get 4 squared minus 2. 4 squared is 16. Minus 2 is 14. So our y-intercept would be 0, 14. Domain, how far left? How far right is this graph going? It's going left forever. It's going right forever. So the domain is going to be all real numbers. The range, how far up and how far down is the graph going? Well, it goes up forever, as we see with these two arrows. And then it stops going down at this point right here where the vertex is. So what does y equal at the vertex? Well, y equals -2. all the other points in this graph are above or bigger than -2 or greater than -2. And then there's one that equals -2. So that means the range of this graph has to be y is greater than or equal to -2. So if you ever can't figure out what number to put here, just look at the vertex. What's the y value in the vertex? That'll always tell you where you're going to put it in the range. If all the points are above or it opens up, then it's going to be greater than or equal to. If it opens down or all the points are below, it'll be less than or equal to. All right, so for example 2, so another equation very similar to the one we just did. So this is my x value. Change the sign. So +3. Here's the y value of the vertex, 4. So 3, 4, I go right 3 up 4. And there's my vertex. If x is 3 in the vertex, then the line of symmetry equation will be x equals 3. Here's the a value, so that's the important one. That tells me whether it opens down or it opens up. So hopefully you recognize that since a is negative, it's going to open down. To graph this, I always like to use the pattern. Again, you don't have to, you can make tables if you want, but this is the way I like to do it. But we always have to multiply the pattern by the a value. So I have to multiply all of these numbers times -2. So if I multiply 1 times -2, I get -2. If I multiply 3 times -2, I get -6. If I multiply 5 times -2, I get -10. And so on. So the first rate of change I'm going to have is -2. That means I go down 2, right 1. And then I do the same thing to the left. Down 2, left 1. Next is going to be -6. So I go down 6. Oops, I forgot to go right. So down 6 and right 1. Then down 6, left 1. Then I would go -10 next, but I don't have room. So I'm just going to stop right there. Make my little U shape. So since our next point would be down 10, right 1, make sure this graph doesn't go past this line. All right, so do we have a maximum or a minimum on this graph? So the vertex is right here. It has a highest point, so it has a maximum. The y-intercept, again, it's not on this graph, so I'm going to have to figure it out by plugging in 0 for x. So y equals -2 times 0 minus 3 squared plus 4. So 0 minus 3 is -3. Oops. -3 squared is 9, positive 9. And then -2 times 9 is -18. Plus 4 would be -14. So our y-intercept is 0, comma -14. So remember, y-intercept always has x equals 0. Domain. This graph goes left forever, right forever, so domain is going to be all real numbers. And then the range, so how far up, how far down? Well, the vertex has a y value of 4, so I know I'm going to have a 4 in there. All these points are either at where y equals 4, or below, or less than, so that means y is less than or equal to 4. We're going to do the next page for our next lesson, so that's it for the notes today.